Imagine carrying something that could wipe out an entire city, or a payload as heavy as a main battle tank. And you have to take it straight through the densest air defense network on Earth. Radar can spot you from hundreds of kilometers away. Missiles can take you down in seconds. You do not get a second chance. But you still have to hit the target. So how would you do it? Because the truth is, this mission once existed. During the Cold War, both the United States and the Soviet Union faced this exact problem. Air defense systems were advancing rapidly. Radar became more precise. Surface-to-air missiles could lock onto targets from extreme distances. Enemy airspace was turning into a true no-go zone. And from that point on, everything began to change. Bombers like the B-2 Stratofortress and the Tu-160 Bear, once symbols of air power, were starting to lose their ability to survive deep inside heavily defended airspace. A question had to be answered. How do you penetrate an air defense system that is almost impossible to penetrate? The answer led to two completely different paths. Two choices that would go on to shape the entire philosophy of air warfare. And from that, two machines were born. The B-2 Spirit and the Tu-160 Blackjack. They are often compared, not because they are similar, but because they solve the same problem in completely different ways. On the American side, the bet was on stealth. Northrop Grumman developed the B-2 Spirit with a flying wing design, eliminating the vertical tail, and using extremely costly radar-absorbing materials. A large aircraft that appears on radar as only a very small signal. Small enough to slip through dense layers of defense with a dramatically reduced chance of detection. A quiet approach, but an extremely dangerous one. On the other, on side, the Soviet Union, and later Russia, chose a different direction. Instead of reducing detectability, they focused on speed and raw power. The Tupolev Design Bureau created the Tu-160, a massive bomber with variable sweep wings and 4 extremely powerful engines. This aircraft can exceed Mach 2, or is equivalent to over 2,200 kilometers per hour, and carry up to 45 tons of weapons. A platform that is faster, heavier, and overwhelmingly powerful in payload capacity. Two different approaches, aiming at the same objective. But in modern warfare, especially in the 2025 to 2026 period, things are no longer that simple. Air defense systems are becoming more sophisticated. Low-cost drones are appearing in massive numbers. The battlefield has changed. And the question now is clearer than ever. Does either of these approaches truly dominate? Or has modern warfare itself rewritten the rules entirely? In this video, we are going to find out. To understand why the B-2 Spirit and the Tu-160 Blackjack operate so differently, you have to look at their design. In air combat, design is not just about shape. It determines how an aircraft survives. And sometimes, a single detail can change how it is used entirely. The B-2 was built with one very specific goal: avoid detection. Northrop Grumman accepted major trade-offs to achieve that. A wingspan of over 52 meters, but no vertical tail. The very component that normally provides stability was removed. The reason comes down to radar. Vertical tails reflect strongly. One large return is enough to give away your position. The flying wing design, combined with radar-absorbing materials, turns a machine weighing around 150 tons into a very small signal on radar. But radar is not everything. Modern systems also track heat. The B-2 uses 4 General Electric F118 engines, without afterburners. The intakes are hidden on top of the aircraft. Hot exhaust is mixed before it leaves the engine. Everything is designed to reduce its signature. The price is speed. Mach 0.95, so just over 1,000 kilometers per hour. Not fast enough to outrun danger, so it avoids danger from the start. In practice, the B-2 goes in first. No need for a path to be cleared. No need for large-scale electronic jamming. It flies straight into defended airspace, hits radar sites and command centers, and leaves before the enemy can react. The Tu-160 takes the opposite path. It does not try to disappear. It accepts being seen. What it relies on is speed and payload. A wingspan of over 55 meters when extended. Maximum takeoff weight of around 275 on tons. On radar, it is a large target. But that is not a weakness it tries to solve. Its strength lies in the engines. 4 Kuznetsov NK-32 engines, each producing up to 55,000 pounds of thrust with afterburner. With the wings optimized, the aircraft can reach Mach 2.05 on over 2,200 kilometers per hour. Very fast. But speed alone cannot carry it through modern air defense systems. If it flies straight in, it can still be intercepted by systems like MIM-104, Patriot, or modern fighter aircraft. So it does not go in. The Tu-160 operates from the outside. From a safe distance, it launches cruise missiles like KH-101, is with a range of around 4,500 kilometers, or high-speed weapons like KH-47M2 Kinzhal. The strike is carried out without the aircraft ever approaching the target. The difference is not about which one is stronger. It is about how each side approaches the target. One sends the aircraft into the danger zone. The other stays at a distance and lets the weapons do the job. These two approaches lead to very different outcomes. In risk, in cost, and in real-world effectiveness. The next section goes deeper into that. Not just how much each can carry, but how much of it actually delivers results. Design determines how you fight, and how you fight determines the weapons you carry. In this section, things become clearer. No longer theory. This is about real damage and the cost of delivering it. If you only look at the numbers, the Tu-160 Blackjack has the advantage, simply because it is bigger. Maximum takeoff weight around 275 tons. 2 internal weapons bays. Total payload up to 45,000 kilograms. It can carry 12 KH-101 cruise missiles. Each missile has a range of about 4,500 kilometers. Newer variants can reach up to around 6,500 kilometers. At Huaim, or that range, this is no longer tactical. It is strategic. The B-2 Spirit operates differently. To maintain stealth, it has to limit payload. Official figures show just over 18 tons of weapons. In maximum conditions, it can reach around 27 tons. Everything is carried internally. A typical configuration includes 80 GBU, 38 JDAM precision-guided bombs, or 16 GBU-31 JDAM heavy bombs. If you only count quantity, the Tu-160 carries significantly more. But war does not stop at numbers. The B-2 does not rely on missiles. It relies on flying directly over the target. And that allows it to use a very different kind of weapon. The GBU-57 Massive Ordnance Penetrator. Nearly 14 tons in weight. Dropped from high altitude, The bomb builds massive kinetic energy as it falls. Combined with a hardened casing, it can penetrate up to around 60 meters of reinforced concrete or rock before detonation. This weapon is not meant for surface targets. It is built for what lies underneath. Hardened bunkers, underground facilities, targets that cruise missiles struggle to reach effectively. The Tu-160 takes the opposite. It is an approach. It does not need to approach the target. From hundreds, even thousands of kilometers away, it launches its missiles and leaves the area. Missiles like the KH-101 carry a warhead of around 400 kilograms. Accurate, flexible, and they keep the aircraft outside the danger zone. But there is one requirement. They have to get through air defenses. Modern air defense has changed dramatically. Interception capability is increasingly effective. Even high-speed weapons like the KH-47M2 Kinjal have been tracked and intercepted in real-world conditions by systems such as the MIM-104 and Patriot. If most of the missiles are intercepted, the strike can fail before it ever reaches the target. At this point, the difference is no longer about quantity. It is about where the risk is placed. With the B-2, the risk is concentrated on the aircraft itself. A system worth around $2 billion, along with its entire crew, has to fly directly into heavily defended airspace. If it is detected at the wrong moment, it does not have the speed to escape quickly. With the Tu-160, the aircraft and crew remain outside the danger zone. But the cost shifts to the weapons. Each cruise missile can cost millions of dollars. A single strike may require dozens of them. And if most are intercepted, the effectiveness drops sharply compared to the cost. The difference is not just in firepower. It is in how that firepower is delivered. One approach brings the weapon directly to the target. The other sends the weapon in its place. Both can cause massive damage. But neither comes without risk. And in many cases, the outcome is not decided by how powerful the weapon is, but by whether it actually reaches towards the target. The next section shifts to a less visible factor: cost, maintenance, and what happens when the aircraft is no longer in the air. Not everything is decided in the air. Some problems only appear after the aircraft has landed. And those problems decide whether it can fly again. The B-2 Spirit was built to avoid detection, but the very material that makes it stealthy creates another problem. Its radar-absorbing coating reacts strongly to the environment. High humidity, rain. The surface can swell or begin to peel, and that alone is enough to reduce its stealth effectiveness. When that happens, the affected area has to be treated and restored. It is not just major damage. Very small details can trigger maintenance. At work, a scratch, a minor impact, even bird droppings. Everything has to be handled manually, one section at a time. And each instance can take hours, sometimes days. Time on the ground reflects this clearly. One flight hour for the B-2 often requires 50 to 60 hours of maintenance. In complex missions, that number can reach up to 119 hours. Operating costs follow that workload. Each flight hour costs around $130,000 to $150,000. At times, close to $200,000. Deployment is not simple either. The B-2 cannot be left out in the open. When operating from bases without proper infrastructure, it has to bring deployable hangar systems. These structures tightly control temperature and humidity. Each unit costs around $5 million. Its overhaul cycle lasts more than 400 days and repeats every 7 years. That means each aircraft is out of service for extended periods. The Tu-160 Blackjack does not rely on such sensitive coatings. Its baseline operating cost is lower, estimated at over $20,000 per flight hour. But its scale creates a different kind of pressure. Maximum takeoff weight is around 275 tons. This requires runways with very high load capacity. As a result, the number of usable bases is limited. A larger issue lies in the engines. The Kuznetsov NK-32 engines are extremely powerful, but difficult to sustain. Production and overhaul have faced long interruptions. The Metallist Samara plant did not produce new engines for an entire decade. A contract to overhaul 26 engines, signed in 2011, delivered only 4 units after 2 years. Shortages of components have limited fleet readiness. The Ministry of Defense of the Russian Federation demanded compensation of around 3.9 billion rubles from Tupolev for failing to meet maintenance and upgrade on contracts. A plan to deliver 4 Tu-160M aircraft in 2025 was only completed halfway. After drone strikes, aircraft were relocated to more distant bases. Distances exceeding 8,000 kilometers, including locations like Ukrainka Air Base. This changes the entire operating model. Each mission can stretch beyond 12,000 kilometers. Flight time can reach around 23 hours. The strain shifts heavily onto the engines, while spare parts remain limited. As a result, the cost per sortie rises to nearly $500,000. No system operates independently of the ground. The B-2 delivers high effectiveness in combat, but demands complex and costly maintenance. The Tu-160 carries heavy payloads and can strike from distance, but depends heavily on infrastructure and production capacity. Air power in the sky is always tied to conditions on the ground. And in many cases, the deciding factor is not the ability to strike, but the ability to sustain operations over time. Theory can make sense, but war does not care about theory. It only looks at results. In early 2026, the United States did not choose a standoff strike. They did not rely on cruise missiles. They sent the B-2 Spirit in. 7 B-2 Spirit bombers took off from Whiteman Air Force Base. They flew more than 11,000 kilometers. A round-trip mission lasting between 37 and 40 continuous hours. No large-scale escort. No heavy dependence on electronic warfare. Mostly relying on stealth. They moved through one of the most heavily defended air defense networks. No early warning triggered. No signal strong enough to provoke a timely response. Then they released their weapons. 14 GBU-57 massive ordnance penetrator bombs from 7 aircraft, striking targets at Fordow Fuel Enrichment Plant, Natanz Nuclear Facility, and Isfahan Nuclear Technology Center. These were all deeply buried targets, protected by layers of concrete and rock. To destroy them, you need something very specific. A nearly 14-ton mass of metal, dropped from around 15,000 meters, carrying enough energy to penetrate up to roughly 60 meters of solid material before detonation. Not every weapon can do that. A missile has to carry fuel and propulsion. It cannot dedicate its full mass to penetration. Here, the result did not come from quantity. It came from delivering the right weapon to the exact point of impact. In mid-2025, where a completely different scenario unfolded. No stealth bombers, no bunker-busting bombs, just 117 first-person view drones, each costing under $2,000, hidden inside civilian trucks, deployed from within Russian territory. They did not fly far. They did not fly fast. But they could reach the target. 5 air bases were hit, including Olenia Air Base, Belaya Air Base, and Diaghilevo Air Base. The drones struck fuel storage areas on the wings of parked aircraft. Large targets. Stationary. The result. Around 20% of Russia's combat-ready long-range bomber fleet was taken out of action. Estimated damage. Around $7 billion. On one side, aircraft worth billions. On the other, devices costing $2,000. The gap was not about technology. It was about how vulnerabilities were exploited. After the strike, the issue did not stop at the number of aircraft lost. To preserve the remaining fleet, Russia was forced to move its Tu-160 Blackjack and Tu-95 Bear farther from the front line. Bases such as Anadyr Airport, near the Bering Strait, Oyas or Ukrainka Air Base. Distances exceeding 8,000 kilometers. From that point on, every mission changed. Flight distances between 10,000 and over 12,000 kilometers. Flight time around 23 hours. The strain shifted onto the engines, while spare parts remained limited. Operational limits sit at around 200 flight hours per year. One mission lasting 23 hours. Repeated 8 to 9 times. That alone nearly consumes an entire year of usable flight life. Costs changed as well. From around $80,000 per sortie to nearly $500,000. Not because the weapons, unchanged, but because the way they were deployed did. After Spiderweb, the issue was no longer just lost aircraft. It was how the entire system began to put pressure on itself. Each takeoff consumed more. Each mission shortened engine life, while replacement capacity could not keep up. The Tu-160 still has speed. It still has firepower. But the conditions required to use them are becoming more limited. It was not defeated in the air, but it is being worn down from the ground up. At this point, the picture is clearer. No more assumptions. The results speak for themselves. The B-2 Spirit demonstrates a very specific capability. It flies deep into defended airspace, places weapons precisely on target, and leaves before the enemy can react. With the GBU-57 massive ordnance penetrator, a bomb weighing nearly 14 tons, it can penetrate up to around 60 meters of concrete or solid rock. Targets buried deep underground can still be hit. But that capability does not come cheap. Operating costs per flight hour range from about $130,000 to $200,000. Deployment requires specialized hangars, costing around $5 million per system. That limits how many can be sustained. And it is one reason why a replacement plan was set in motion long ago. The Tu-160. Blackjack takes a different approach. Keep distance. Strike from range. Reduce risk in the air. But its large scale becomes a vulnerability on the ground. And that vulnerability has already been exploited. In the Spiderweb operation, 117 first-person view drones, each costing under $2,000, were deployed directly against airbases. Around 20% of Russia's combat-ready long-range bomber force was taken out of action. Estimated damage, about $7 billion. After that, the remaining aircraft had to move farther away. Distances exceeding 8,000 kilometers. each mission stretching to around 23 hours. Cost per sortie rising to nearly $500,000. These changes did not come from the original design. They emerged when the method of deployment was forced to change. New programs are moving in a different direction. The United States is developing the B-21 Raider. Planned scale: between 100 and 145 aircraft. Deirdurzer, an aircraft retains stealth capability, but with more durable coatings. No need for specialized hangars. Operating costs reduced by roughly half. On the other side, the PAKDA has yet to show clear progress. Upgrades to the Tu-160 M2 are still ongoing. At the same time, another trend is accelerating. Drones, artificial intelligence, high-speed weapons, systems that are smaller, cheaper, and deployable in large numbers. What was once considered the standard of power is changing. Large systems still have a role. But how, and they are used, has already shifted. War does not stand still. And what is coming next will not look like the past.